Hello everyone, this is Adam. Welcome to the video tutorials about TraceLab. In this video I'm going to show you how to create your component in C# in Visual Studio. I already have my TraceLab open, as you see, with the simple experiment that loads some collection of artifacts. In this case I'm using COES artifacts collection, and now I load the data from the tutorial sample files provided to you. If I execute it, then you can actually view some list of artifacts that I'm going to reprocess. What I'm going to implement, I'm going to implement another version of the stopwords remover. In this case, this stopwords remover is taking the list of stopwords. I want to do it differently. I want to be able to provide this information in the configuration without need of implementing anything else. So in this tutorial I will show you how to build a component that loads some data, process that data, takes some input from the configuration and outputs the processed data. So let's go ahead and open Microsoft Visual Studio. To create the project, TraceLab project, I'm going to click on File, New, Project, and under the section of Installed Templates you can find TraceLab and the TraceLab component project. You will see that TraceLab component project only if the Visual Studio had been installed before you installed TraceLab. Otherwise you may not see it, and you should first install Visual Studio and reinstall TraceLab. I'm going to change my name. It's like, let's call it new stopwords remover, and I'm going to save it in another location under documents, TraceLab, in the new folder component source. I just like to having my source closer to the actual components, and I go ahead, click OK. You will see initially it will show you the simple wizard in which we will provide the information about some references to the TraceLab SDK and the TraceLab SDK types, as well as output directory. So TraceLab SDK contains all of the information about all of the SDK API classes that we need to create our component to communicate with TraceLab. You will find that SDK in the C program files COES TraceLab lib TraceLab SDK DLL. Open. The types are this is the optional thing. The types are located under TraceLab types folder. You don't have to provide it, it's optional only if you are going to use the data structures provided from TraceLab. Finally, the output directory is the directory to which the final assembly is going to be copied to, and that's the directory which TraceLab will scan in search for your component. You can define those directories in TraceLab in the settings, and one of the standard TraceLab directories is here under TraceLab components. I'll show you in a moment where you can define your own directories in TraceLab. So as you see, our solution has been created with the project new stopwords remover, and under references you will see the references to the TraceLab SDK types and TraceLab SDK. Let me just go quickly back to TraceLab, and I'll show you where you can see which directories are being scanned for the components. As you see, we scan the program files, we scan also users documents, components. You can define your additional paths for the components. So you find it here under the settings. Let me go back here and let's continue. To create your new component, you just go to Add and New Item, as you see, and then under Installed Templates you select TraceLab, and you will see another template called TraceLab component. I'll change the name of that file to new stopwords remover. Okay, similar like before, we have like small, very easy wizard, and now I'm going to fill it out. New wizard component, not the wizard component, I'm sorry, new stopwords remover. This is new stopwords remover. Of course, we would provide more information here how to do that, and my name is Adam, so I'll just provide myself as the author, right? So let's see what happened. Our template of our component has been generated. First of all, you have the class, public class, that extends the base component. The base component is the abstract class. You see here, it's an abstract class that you have to extend in order to implement your own class. And it has several things. It has the abstract method compute. It has two virtual method post compute and pre compute that you can also overwrite if you want. They are simply executed before compute method and after compute method. It also has three properties, which is the workspace. This one allows you to load the data and store the data to the workspace. It has a logger that allows you to log certain information to the to TraceLab. As well, you have the configuration object that you are allowed to set, which I will explain in a moment. And it also has the protected constructor that you have to extend. So let's go back here and let's see that actually that what's happened. We have the line of our constructor, new stopwords remover, that takes that component logger and calls the parent constructor. We also already override the abstract method compute method, and the first thing that we are doing is we just have a logger that calls trace and writes hello world. So that's all we have in here. As you see, I didn't change anything at this moment. So let me just go ahead and just build new stopwords remover. And what happened that it compiled it and it copied one file. To see where it has been copied, you can actually go here to new stopwords remover project, right click on properties, and then under build events you can see that post build event command that copies the target path, which is the initial path from output path bin debug in this case to previously defined output directory here with the target file name. So if you need to change it, that's where you change it, or if you forgot to provide it before. So let me close it and let's actually go back to TraceLab. Before I will rescan, let me find the stopwords remover. We have stopwords importer. We have some other my stopwords remover, which from my previous test. But the one that we had, it was called new stopword remover. So now if I rescan the library, right, and I'll search it again, stopwords, we actually have a new stopwords remover here, right? Adam, this is new stopwords remover, the one that we have just created. So let's see if I drag and drop it here, and I connect it. Let's see what we have in here. We don't have any inputs and outputs, and we have our initial component info, the one that we provided in the attributes. If I execute it here, let me clean it here, and I run it, right? We have information hello world with the trace log level. So now let's see what I can change at first. What I didn't show actually, and I didn't explain that attribute fully. So as you see, we have the things like name, description, author, and version. Note that the ID, the unique ID of the component, is being provided with, is being automatically computed by TraceLab. and it's being computed based on the name, version, I/O specification, and configuration. So if you change any of those four things, it will affect the existing component, and all the experiments that were referring to that component by old ID, they will not see that component. So let's see, for example, change. Let's say I just added something here to the name, and I will compile it again, and I'll go rescan. This component will turn on red. You see, it turned on red, and actually tells you that the component library does not have any component of the given ID. And the reason is, let's see, we have the stop words, because we changed the name. In essentially, it's a new component. The same would happen if you change the version, and the same would happen if you added something to I/O specification for the inputs or outputs, or if you change something in configuration. The same thing would happen. So let me go back for a moment, and I'll just remove it, and I compile it again. Shift F6 and rescan the library. This will go back to the same things, because it's exactly the same definition of the component, right? So one of the things that you don't see here is a default label. Default label allows you changing the name, I mean the label of the component without affecting that ID. So I could have a new stop words remover demo, let's say, right? So now if I compile it and I will rescan it, nothing will change, although the default label has changed actually to the new stop words remover demo. So now if I drag and drop it, I have the demo here as a default. So that's one of the things that was not in the template. Another interesting thing here, apart from that, from the simple thing, is a tag element. The tag element allows you to define the category to which the component belongs to. So I can say preprocessor, for example, right? So that would be one tag to which it belongs to. So now if I compile it and rescan it, then I will see the component under not only all components, but I will also see it under preprocessor. Sorry, I made a mistake, so I have my own category, as you see, right? You can do you can have a multiple tags, so I can have my preprocessors, for example, as well, and I can have, like, for example, the situations like this, stop words, right? Removers, right? So I can actually type something like that, and it's going to be under preprocessor, under preprocessors, and preprocessor stop words remover. So let's see how it looks like, and if I compile it, then I will see it under preprocessors. There it is, preprocessor, there it is, and the preprocessor stop words removers, there it is, right? So of course I could, for example, remove it here and just keep it like that, right? Or like that. So I think you understand it. This is an easy concept here. It just allows you to organize yourself a little bit better. So okay, let's do some more serious stuff. As you see here, I have the line that has been generated for me, which is the I/O spec line. I/O spec attribute allows us defining what the output and input comes in or out from the component. So it has essentially three required parameters that you have to provide. One is the I/O type, which defines basically whether it's an input or output. So this is just the enum value. Let's say in this case I'm defining name, I mean input. Then it has a name, which the name is the name of the parameter, the internal name of the parameter that you're going to load the data from the workspace. So for example, some artifacts. the data type is the type that you are going to load. So for example, I will have a TL artifacts collection, and that's the one of the types from the SDK types, and I'm just adding it to the using so that I can see it. One of the parameters that you don't see here is the description that allows you to define the tooltip that shows this is artifact collection to process, right? So let me now compile it and rescan it, and note that I changed my definition of the component, so this is not up-to-date component anymore. So I actually have to drag it again, right? So in this case I have some artifacts while the old one didn't have it, so that's why we had to drag it again. So as you see, in this case already I have some artifacts and I can map it to whatever was before outputted. Of course I'm not doing anything with that, so if I execute it I still have just a hello world. So let me save it and go back. So let's do something like this one. I mentioned before that loading of the components is done via property workspace. So if you type workspace load, you have here the method that requires the unit name. The unit name is exactly the same one like you provided here, right? So some artifacts, right? So let's see var my object, right? Note that the load method loads object. If I made a mistake, right, then the situation is going to be following. In this case I just rescan. Actually I even didn't have to rescan. It will show the error that the component has not declared any input of the given name some artifacts xxx. And that's true, you didn't declare any name. You declared some artifacts but not some artifacts xxx. So if I go back to this one, then I can actually compile it and it should work, right? Note that I had it remapped to something else, so the some artifacts is the internal name of the component that you are using, but it allows you to map it to anything else that is in the trace, right? So once we have this one of the things to remember is to actually check for no nulls. If object is equal null, then throw some exception. I'll show you in another examples how such exception would show up, but there is one difference. If you have the argument exception or argument null exception or any other exception that is different than the component exception, which should be you need to add that using here, then it will show the exception stack in the TraceLab. I'll show it later on with another example, because at this moment I cannot produce the null artifacts, or the other way. I'll show it this way. I'll just remove it for a moment, and so this is error, right? Let me just compile it, go back here, run it, right? This is error, and it just shows here this is error, right? But it doesn't show the exception details. If I just do it differently, if I throw another exception, argument null exception for example, and compile it and run it, right, then it will show exception occurred in the component, view exception details, and you can see the stack trace. In other words, this allows you to define which components are handled by you, so you are aware about them from those exceptions that are not handled, that are unexpected. That's how it is done. In this case, I'll just do component exception, component exception, and I will just say cannot accept null or empty or null artifacts. Of course, you provide some information that is understandable to the user, right? So now let's do some iteration over that. So let's say artifact, and I forgot to cast it. So tl artifacts collection equals tl artifact collection object, right? So now I can actually iterate through that. Since the artifacts collection actually extend the dictionary, as you see in here, which is the so you can actually iterate either over the values, or you can iterate over the key value pair. So let me just go over key value pair, and in this case let's do this one. Sorry for this. String artifact collection key value pair resolve. Good. So we are good, and of course we can do some pre-processing here. So let's say debug, for example, artifact key, right? So now let's see if I execute it, Shift F6, right, and I run it, right, then it prints out lots of messages, some numbers. So let's see actually whether list of artifacts has the artifacts ID as numbers. So that's correct, right? So now you can imagine that we can do some processing here. So for example, we can have the method ready here. So let me just copy that method. So I'll just add one additional method here, which is process with some string builder that takes text to process and the hash set of stop words, right? So let me just quickly create hash set of string of stop words and new hash set of string of stop words, and let's add some stop words here. Add let's say A, right? And then we just can call string processed artifact equals process, and we have the artifact value, and that should be text, right? And the stop words. So in this case the process artifact is going to be the process artifact, and then of course we have to assign that to the artifact value text processed artifact. Notice that the collection that you're receiving by the workspace load is actually the copy, exact copy of what is in the workspace. So there is no race condition with other components when you got to the component. So you are safe to do anything on that collection, and it's not going to affect the work of any other components that are working at this moment. So once I have something like this one, I can do workspace store with some output name. Of course, you can imagine that if I do this, let's see, it won't. Oh, where is I lost my where is if I do this, right, it tells that component has not declared an output of the given name, output name and type system integer, and yeah, because I was trying to store integer. So let me change it to the collection. Well, so what means that actually we have to add our IO spec here. So let me do that. IO spec IO type equals IO spec type output name, let's call it processed artifacts, for example, data type the same as above, type of TL artifacts collection, and that's it. Yeah, you could provide the description as well if you want. So let's process artifacts that it matches, and let's see what will happen. Right, so Shift F6, right, we change our declaration of the component, so unfortunately we run it, oh, we forgot to rescan. The error will change that actually we don't have any component, and we have to find that component again and drag and drop it, right, and connect again. So anytime you change anything to the declaration of the component, you essentially create a new component. It's annoying at the beginning, but then it prevents the situations in which you forgot to update the GUID or something like that. So, oh, I didn't show you. You have the tooltip as well in here, right? So let's just what happened. I don't know. The previous component output some artifacts, so let's just map it. Yep. So let's see here. Oh, we have process artifacts, right? And this one is not supposed to have an A's. Do I see an A? Let me just go with the D, because let's add here one more stop words at the. Okay, so some of those. Shift F6, run. So list of artifacts has the, and let's see if my method worked. It allows operator, so there is no the. So our method worked, right? So now the final thing is to see how to do the configuration. I don't want to have hard-coded stop words. I want to get those stop words from the configuration. So the configuration, you have to modify the component's attribute. The way you do it, you just go here and you just type configuration type equals, and you provide the type of the objects that you want to provide as your configuration object. So let me call it new stop words remover config, right? I don't have that class yet, so I just go ahead and I will generate the class, right? So my class has been generated, as you hear it appeared here, and if I go there, then this is my class, right? In that class here I can define my properties, right? It has to be public. It has to be public, and then you can provide here the properties that you want to. So for example, public string stop words with get and set. It has to be public, it has to have a get and set. That's the one that we will recognize as the property. What you can do here, you can define a display name, which is in the namespace of system component model. So you can have a different property name and a different display name. So for example, all stop words, for example. And then you also can provide the description from the same namespace, and then the description is the tooltip over that configuration property. Provide stop words, right? Of course, you write thing is, but that's not all. We have our class, but then we have to do one thing more here. We have to actually we have to create that object in our constructor. So new stop words config equals new new stop words config, right? Cool. And we have to assign that one to the parent property, right? So config, and that's it. That would already work, and you could read it. So let me just compile it. We changed our attribute, right? Our definition of the component. That one didn't have the configuration. So if I rescan it, right, this one disappeared, right? Let me go remove it, and I have to drag and drop it again. Boom. So now what you have in here, you have stop words, right? And here we will be providing our stop words, and so on, so on. Let's say we decide to provide them delimited by the semicolon or by space, maybe, or that would be better, probably, right? So let me connect it. Save it, and let's go back here. So once we have it, we of course here in our compute method we have access to the compute method, right? We have access to configuration object, but each time we would have to cast it. So what I usually do, I actually do my private new stop words connection config, right? And I assign it here, right? So this time I'm just accessing my configuration object by that private member rather than casting each time configuration object. So that's just, but you can cast it, that's not a problem, right? So now let me go ahead and do the pre-processing. So I don't have a code, so I have to quickly think about it. So that will be a char. No, how was that? Stop words, that's the hash set. So let's go to string. Let's say stop words tokens or terms equals config stop words as a string, and we should have a split method here that takes the parameter of the char. So that would be new char. Yeah, I'm improvising in this moment, so I'm sorry for this. So hopefully I will not make any mistake. That should be right? So we have a stop words terms, and now we can actually iterate for this one for each string term in stop words terms, like this. But then we want to have a stop words before that, right? And if I didn't make any mistake, then possibly we should be able to add term here. Am I correct? And that should work. Let's see. Okay, we compile it. We go back to TraceLab. Let me find TraceLab. We scan it. Actually, you don't have to rescan if you didn't change the definition of your component. Basically, what happens each time when you run the experiment, it actually loads the assembly at this moment. So in this case, oops, I forgot to map it. Let's see. A list of artifacts has the, and process artifacts does not have the. So all is good. Our component had worked. So before I finish this demo, let me go back here, and I'll just try to talk a little bit here about some of the best practices. So what is the good thing to do is actually to limit your compute method to just storing loading and storing methods from the workspace, and the rest of the stuff, processing stuff, do an external method or an external class. So in this case I would just go ahead and let me just do maybe a little bit of refactoring that will just have that casting beforehand, right? And now let's do the refactor extract method that takes the artifacts collection, and let's call it process collection, right? I want this method to be static, and we will complain about the configuration. So let's just pass that new config. You could possibly provide just a hash set here, which is also valid, right? What it gives to us, it limits our method compute method just to very basic checking for the workspace load. We could do additional checking here for the configuration parameters, but what it allows us to do is to actually test this method without bringing up all the TraceLab overhead, workspace, and so on and so on. It would be possible to implement the mock workspace, but that's just overhead, and all you want to care is all you care about is actually testing your method. If you need to have some state, have another class that does all the computations. So that's the best practices that I would recommend to do to avoid any problems. And also think about the defensive programming. So all the checks like that are actually important. And alright, so that will be it. We created our component. I hope that this is not too complicated. As you see, everything works, and I hope it explains all of that.